So now that we have all of our theory, we can actually look at objects in motion. And as we're studying objects in motion, we're going to be looking at graphs. And there's actually three different types of motion graphs. The first one we looked at was a position time graph. Position time or displacement time graph. And a position time graph, remember, we can find the velocity by finding the slope at any point in time. Second graph we looked at was a velocity time graph. Velocity time graph, again, if we wanted to find the acceleration, it comes from the slope. And if you go on and do higher level physics, you're going to look at a acceleration time graph. And an acceleration time graph, same thing, acceleration on the y, time on the x, and you're going to study that slope, etc. And that's for higher level physics classes. But the important part about these graphs is we can use each of these graphs to analyze the motion of an object. Or if we have multiple objects, we can actually compare the two different motions. So let's use the graph. And when we are looking at graphs, the important thing is that we look at the y-axis. We want to find out what is the graph representing. And this actually represents a velocity time graph, the motion of a bicycle. From a graph like this, we can find a number of things. We can find the instantaneous acceleration, the slope at any point in time. We could find the average acceleration, the acceleration over the entire motion of this object. We could also find the displacement at any time by finding the area under the graph. Let's actually do some calculations then. So let's find the acceleration for the first 5 seconds. We want to find the slope of that graph. Now we can also find the acceleration by using our formula of change of velocity over change of time, but either way from this graph, whether we find the change in velocity or just find the rise over the run, it's still going to give us the same solution. Our final velocity is 8 meters per second, initial velocity is 2 meters per second, and we have a run of 5 seconds. And just do some simple calculations there. 8 minus 2 is 6 divided by 5 gives us 1.2 meters per second squared in the east direction. It's a positive slope, so it would be in the east direction. Well, what if we wanted to find the acceleration from 5 seconds to 15 seconds? And 5 seconds to 15 seconds is pretty easy to see on the graph. This is where we have no slope. So we have no acceleration. The acceleration is 0 meters per second because we have just a horizontal line. The slope is 0. No need to do any calculations. We can just interpret from the graph. Well, what if we wanted to find the average acceleration? And the average acceleration would be over the entire motion. This is a little bit different. Average acceleration, what we need to do is we do need to find our v final and v initial, and we start at our starting point. We started at 2 meters per second. The final velocity is 8 meters per second over a total time of 15 seconds. 8 minus 2 is 6 divided by 15, and in this case we'd have 0.4 meters per second squared east. So what we have to notice in this question is, are we talking about average acceleration for the entire motion, one point in time, or just finding one particular slope? Well, what about displacement? And displacement is really the area under the graph. We want to find the area under the graph for the first 15 seconds. This graph, what we need to do is break it into chunks that make the area easier to determine. So we just draw some lines in. We got a triangle, a couple rectangles, and to find the displacement, we just find the area of each of those shapes. So if we start with the triangle, area is base times height divided by 2, or 1/2 base times height. We are going over 5, up 6, times 1/2. Well, let's find the small rectangle. A small rectangle has a length of 2 and a width of 5, and the big rectangle, length of 8, width of 10, and we just fire those numbers in your calculator, and in the end we're going to get a positive value of 105 meters east. So we just have to find shapes that we can easily calculate the area to find the displacement. Well, let's look at one last piece, which is called terminal velocity. You may or may not have heard of this term before. Sometimes we have forces that are actually pushing up, such as air resistance, to reduce acceleration due to gravity. And this is a situation where something's falling to the ground. Sometimes the force up is reducing the force down, the gravity. And in a situation when the force up actually equals the force down, your object does not accelerate anymore. So an object will stop accelerating and it will travel at a constant velocity. And this constant velocity is called the terminal velocity. This is the fastest that the object can travel. Now it depends on a number of things, the biggest one being surface area. So an example, if you are skydiving and you're laying belly down, arms stretched out, you create a large surface area. And you would reach terminal velocity in about 16 seconds. At this point, you would be traveling 200 kilometers an hour. Clearly a very, very fast speed. And if you ever see skydivers, you'll see them trying to control their speed by increasing or decreasing their surface area. Obviously, if we decrease the surface area, turning around, maybe not laying belly down, tuck your legs in, you're going to go faster. But you will reach a terminal velocity of 200 kilometers an hour if you increase your surface area. And you won't get any faster than that. And that takes us to our end of our study of motion.